Walaikum assalam. We are just starting in a couple of minutes, inshallah. I'm just setting a couple of things up, and then we begin, inshallah. पिछले जगह बैठा ना बताया था मैंने। Okay, assalamu alaikum everyone. I hope you're all well. We will be starting now, inshallah. We're doing 3 papers today, difficult questions from 3 papers from June 2025, paper 1, paper 1, 2, paper 1, 3. This is IGCSE O-Level Ad Maths. We're doing difficult questions from 3 different non-calculator papers from June 2025 session. Okay, that's the plan for today, inshallah. These are free past paper sessions that I'm conducting. If you want to join, you can have a look at the link in the description. You'll find a lot of other resources, links in the description, like revision videos and other difficult questions videos from recent papers. Chal, let's begin with this. June 25, paper 1-1. Let's start with some questions from this paper first. I'm looking at the poll posted in the WhatsApp group and seeing which questions you asked about from this paper. So first of all, from this paper, I can see that there are a lot of words on question number 6. Okay, question number 6, this is the first question that we will start with. This is the question that has a significant number of words first up. Let's begin with this. Okay, I'm just going to open that window here as well. Let me just erase it from, get rid of this from here. Is it working now? Okay, all right. So it's all set up. Let's begin. So first of all, June 25, paper 1-1, we're doing difficult questions from this paper first. Question number 6, that's the first question that you guys asked about from this paper. Let me copy that here. Question number 6 from this. This is part A of this. Let me copy the other parts as well. Part B and C. Okay, so this is the first question that we're doing, question number 6 from June 25, paper 1-1. Let's begin with this. Achha. Now, first of all, they're saying A curve has this equation. We need to show that dy over dx, that means the derivative of this curve, that can be written as this. Walaikum assalam, Azim. I'm doing well, alhamdulillah. Let's find the derivative of this. How do you do that? It's a fraction and there's a power on top of that. It's a fraction with a power on top of that. We can use the power rule on this, right? Let's apply the power rule on this and see what that gives us. Dy over dx. Multiply by the power, so we multiply by 4. Subtract 1 from the power x square minus 1 divided by x square plus 1 whole raised to the power 3. We subtract 1 from the power. Then we multiply by the derivative of what is inside, derivative of this thing. What's the derivative of this going to be? Derivative of x, this is numerator, this is denominator, right? X square minus 1 divided by x square plus 1. It's a fraction. We can use the quotient rule on this, right? Let's use the quotient rule. Vu dash minus uv dash divided by v squared. Okay? Let's input values in that. Now in this case, u is x square minus 1. U is x square minus 1. Okay? And v is x square plus 1. What is u dash going to be? Since we have to input that here, it's often a good idea to just evaluate them on the sides to reduce careless errors. U dash is 2x, v dash is also 2x in this case. Let's input values in this. Let's input values. What do we get? Vu dash. V as it is. V as it is. That means x square plus 1 as it is into u dash, which is 2x, minus uv dash, that means x square minus 1 into v dash, which is 2x, whole divided by v squared. What is that going to be? X square plus 1 whole raised to the power 2. Okay, this is what we end up getting. So we have just applied the power rule, we multiply by the power, subtract 1 from the power, and then multiply by the derivative of what is inside the bracket. Okay. Let's simplify this. In the numerator, we have 4 into x square minus 1 whole cube divided by x square plus 1 whole cube. This cube will go to the denominator as well, right? This is a square. Let's write that here as well. X square plus 1 whole squared. So we've got what we wanted in the denominator, right? X square plus 1 whole raised to power 5. So we've got that in the denominator. What about the numerator? If we simplify the numerator, we should get what we want there as well. Let's simplify the numerator and see what that gives us. Simplify the numerator. 2x into x squared, that's 2x cubed plus 2x. Minus 2x into x squared, that is 2x cubed. Minus 1, that's plus 1 into 2x, that will be plus 2x. This is what we get in the numerator. Now let's simplify this further. 2x cubed and minus 2x cubed, they get cancelled. Okay, so now let's simplify this further. What do we get from this? 2x plus 2x, what does that become? 4x. 4 into 4x, that will be 16x in the numerator, right? This 2x and this 2x, that's 4x times 4, that's 16x. This is x square minus 1 whole cube. In the denominator, we have x square plus 1 whole raised to power 5. And that's what we wanted. This is what we had to prove in the first part. What is it that we're getting in place of a here? In place of a, we're getting 16. We could write down that value as well. That's the derivative. That's the derivative. This is what we were looking for. Okay, that's our final answer. Makes sense, right? That's part A. Okay, chale. Let's look at the next one now. Let's look at the next part. Now, what are they saying in the next part now? Show that the curve has stationary points where x is -1, x is 0, and x equals 1. Achha, now, the derivative that you're getting is this, right? We have to show that the stationary points are at these 3 points. It's a 1-mark question. How do we do this? Just put the derivative equal to 0, 16x into x square minus 1 whole raised to power 3 divided by x square plus 1 whole squared power 5, sorry, equated to 0. What do we get from this? This denominator that gets multiplied by 0 on the other side, and we are just left with 16x into x square minus 1 whole cube. That is equal to 0. Either 16x is equal to 0 or x square minus 1 whole cube is equal to 0. This gives you x equal to 0. The other one gives you x square minus 1 equal to 0. X square equals 1 and x equals plus minus 1. And that is what we had to show. Another way to do this could also be that you could input x equal to 0 in this, input x equal to negative 1 in this, and input x equal to 1 in this, and show that all of them are giving you 0. That could be another way of doing this as well. That was just one mark. Still required some working, but it was fairly straightforward, right? That's your final answer. ठीक है, चलिए, let's look at the next one now. That's part B1, part B2. Let's look at this now. It says use the first derivative test to determine which two stationary points have the same nature. Okay, how do we do this now? How do you find nature of stationary points generally? How do you find nature of stationary points? In general, what you do for that is you find the second derivative. Right? You find the second derivative. If the second derivative is positive, you say it's a minimum point. If the second derivative is negative, you say it's a maximum point. The problem here is, number one, they have told you to use the first derivative test, so we can't use the second derivative. And number two, finding the second derivative from this is going to be pretty complicated, right? You'll have to use quotient rule again. In the numerator, you have a product as well. So you'll have to apply a product rule for the numerator separately as well. That is going to make things very complicated in any case. That is the reason they have told us to use the first derivative rule, the first derivative test. Now, how does that test work? Let's think about it. If it's a maximum point, remember what happens? If it's a maximum point, on the left side of the turning point, dy over dx would be positive. And on the right side of the turning point, the dy or the derivative would be negative if it's a maximum point. For a minimum point, it will be the other way around. For a minimum point, we would have negative derivative on the left side. This would be negative. And on the right side of the turning point, it will be positive. So all we have to do is we have to figure out the value for the first derivative on the left side and on the right side. Okay. Now, how do we do that? For each of those points now, we need to do that. Which two station points have the same nature for that function now? So we know the stationary points is they're at 0, 1, and negative 1. So first of all, let's write down the first derivative. What's the first derivative that we found above? It was 16x into 16x into x square minus 1 whole cube divided by x square plus 1 whole raised to power 5. This was the derivative that we found. Okay? This was the derivative that we found. We need to figure out the value of the derivative around these three turning points now. Around x equals 0, x equals negative 1, and x equals 1. 0, 1, and negative 1. Take points around them. Now, which points can we take? Just think about it. So we have 3 points. Let's write them down like this. I'm just going to show them on a number line. There is a point There's a turning point at -1, there's a turning point at 0, there's a turning point at 1. So we will need to use a value here, maybe a value here, a value here, a value here. Okay, let's try some values. What can we input? On the left side, we could try -2, for instance. Let's see what happens at -2. If we input x equals -2, what do we get from that? Let's try. If we input x equals -2, what does the derivative turn out to be? 16 into -2 into -2 whole squared minus 1 whole cube divided by -2 whole squared plus 1 whole raised to power 5. Achha, now it does not matter. It does not matter what the actual number is. It does not matter what the actual number is. All that matters is whether the value is positive or negative. So we don't have to necessarily calculate what the actual values are because it's a non-calculator paper. It's going to take time to be able to evaluate the exact numbers. Just think about whether the numbers are turning out positive or negative. So in the numerator, you have -32 outside. Inside the brackets, you have 3 cube. Right, this is 4 minus 1, that becomes 3 cube. In the denominator, you have 4 plus 1, which is 5, 5 raised to power 5. Now don't evaluate this number, just say it's negative. It's a negative number. So we figured out towards the left side of -1, towards the left side of -1, here the derivative is negative. Let me write that on the side here. Dy over dx. On the left side, this derivative is turning out to be negative. That's all that we needed to figure out. Okay. Once we figured this out, let's try what happens between these two numbers. Let's see what happens between these two numbers. You can try maybe -0.5 and see what that gives us. X equals -0.5. Let's see what happens there. Again, all that matters for us is whether it's a positive number or a negative number. In fact, if you think about it, the denominator is always going to be positive, right? The denominator is always going to be positive because the denominator has a square and then there's +1. So it is always positive, raised to power anything. It's only about the numerator, whether that is going to be positive or not. So in this case, when we put -0.5, what do we get from that? -0.5. That gives us into -0.5 whole squared minus 1 raised to power 3. In the denominator, we have -0.5 whole square plus 1 whole raised to power 5. Acha. Now think about it. The denominator is positive, right? So denominator is positive, that's all that matters. Just say it's a positive number in the denominator. What about the numerator? 16 into -0.5, that's a negative number. You can write that value as well, that's -8. What about inside the brackets? Inside the brackets, we have a negative number. Why? Because 0.5 squared is going to be less than 1. So 0.5 squared minus 1, that's going to be a smaller number than 1. 0.5 squared minus 1, that is going to become negative number, right? And then you take cube of that, that's still negative. So we have a negative number outside, a negative number cube here. This is going to give you a positive number, right? Because in the numerator, we have two negatives. They become positive. In the denominator, we have a positive number. So the overall fraction becomes positive. So that tells us between these two numbers, we have positive. So does that tell us anything about -1? Is that a maximum point or a minimum point? On the left side, we have negative gradient. On the right side, we have positive gradient. That's a minimum point. So this point is a minimum. We figured that out. Okay. Achha. Let's see what happens at between 0 and 1 now. Let's see what happens there. You can try 0.5 this time. Now, you don't necessarily have to show all of this working. Once you have done a couple of them, you would be able to figure out, okay, what is going to happen at 0.5? You could write down the derivative, whether that's positive or negative. directly as well. So for example, if you input 0.5, in this case, you see what happens in the numerator. We have 16 into 0.5. It's a positive number. The denominator we know is always going to be positive no matter what number we input, because as we said earlier, it's x squared plus 1. That's a positive. In the numerator now, inside the brackets, we have 0.5 squared minus 1 whole cube. Now, outside we have a positive number. Inside we have a negative number whole cube. The denominator is positive. The overall result turns out to be negative in this case as well. Okay, so this is negative now. And then what happens after 1? You can try maybe 2 now. On the right side, see what happens at that point. X equals 2 dy over dx, that is equal to 16 into 2 squared minus 1 whole raised to power 3. Denominator we know is positive. Numerator is also positive, right? All positive numbers. So this turns out to be a positive number. And we say this is positive here. Okay, now this is the key part that you need to show. This working, some of you will be able to, think about it mentally as well, and that's perfectly okay. I just wrote everything down so you understand the process. If you're okay, this is how you would think about it. But eventually, now what we're getting is here the derivative is positive. On the right side, it is negative. So what about 0? Can we say anything about 0? It's going from a positive derivative to a negative derivative. That's a maximum point. So this is maximum. And then negative to positive, this is a minimum. So to answer that question now, whether they are maximum or minimum points and which two stationary points have the same nature, the two stationary points that have the same nature, no, you don't have to show all of this working. You don't have to show all of this working. This is just for understanding what you're doing. So if you can figure this out mentally, as in this is what you would think about, right? What the numerator is going to be, what the denominator is going to be. Just figure out whether that's positive or negative. You can write down the value of the derivative after that. Whether just the sign of the derivative. This working is not necessary. This working is not necessary just for understanding the process that you may be doing in your head directly. Okay? Acha. Now, this is the key part. This is the key part that you need to show. They will mark you for this. They're going to mark you for this, what I have shown on the right side here. This is the important part. This is the important part. Okay? How the derivative is changing. This is important. So now you can write down, you can say x equals minus 1 and x equals 1. Both of these are minimum points. Minimum points at x equals negative 1 and x equals positive 1. That will be your final answer. So this is the key part. This is the key part. Okay, that was fairly tricky. That was fairly tricky. Because we don't have calculator allowed, because of that, it did require a lot of thinking. Okay, let's move on to the next one now. Let's move on to the next one. So the next question that you asked about from this paper. Okay, question number 6. After this, we have question number 10 and 12 from this paper. 10 and 12. Okay, two more questions from this paper. Question number 10 and 12. Let's try that. Let me copy them here. Question number 10. जी मैं खोलता हूँ एक मिनट रुको बस थोड़ी अभी थोड़ी देर. Just give me a second. Okay, I'm sorry about that. चलिए, let's do this now. Acha. Given that theta is between 0 and pi over 2, that means it's in the first quadrant, right? It's an acute angle. It's an acute angle, it's in the first quadrant. Show that it can be written as secant theta, this whole expression. Okay, how do we think about this? We have square roots and we have inside the square root cosecant square theta minus 1, 1 plus tan square theta. Now to simplify the square root, since we don't have a square root in the final result, let's see if we can use any identities. Can we use any identities? Can we use any identities? Let's think about it. Sine theta divided by square root of cosecant square theta minus 1 plus 1 over square root of 1 plus tan square theta. Achha. Now, what is 1 plus tan square theta? 1 plus tan square theta, we have an identity for that, right? 1 plus tan square theta is identical to secant square theta. So this fraction, we can simplify the denominator for this and write it as secant square theta. Acha, what about this other thing, cosecant square theta? Do we have an identity for cosecant square theta? It's given in the formula sheet as well, right? We have 1 plus cot square theta, that is identical to cosecant square theta. If we rearrange this, we can say cot square theta is identical to cosecant square theta minus 1. So we could simplify this denominator as well. Let's do that and see what that gives us. Sine theta divided by square root of cosecant square theta minus 1, that will be square root of cot square theta, plus 1 over 1 plus tan square theta square root, that will become secant square theta square root, right? Now we can simplify the denominators. What does this become? Sine theta divided by cot theta plus 1 over cos theta. Cot is reciprocal of tan, secant is reciprocal of, okay, I'm sorry, 1 over secant theta, not cos. Now, cot is reciprocal of tan and secant is reciprocal of cos, right? What we can do now is, since we want secant theta at the end in the numerator, it's often easier to just convert everything to the base function, sine, cos, tan. So what about cot? Cot can be written as 1 over tan. So we have tan in the numerator, and tan is sine over cos. So we could say sine theta into sine theta over cos theta, right? So cot, this simplifies to sine theta over cos theta like this. What about this 1 over cos theta? We can write this as cos theta. Okay, now we need to simplify this further and write it as secant theta somehow. What can we do after this now? What can we do after this? In the numerator, we have sine square theta. What we can do is we can take LCM, sine square theta. Yeah, so that is going to work. Sine square theta plus cos theta into cos theta, that becomes cos square theta. In the denominator, we just have cos theta, LCM of these two numbers. And now we have got to that final result that we wanted, because the numerator is just 1 now. Sine square theta plus cos square theta is 1. In the denominator, we have cos theta. Cos is reciprocal of secant. So we can write this as secant theta as well. And that is what we were looking for. This is the same thing as the right-hand side. Okay, so often when you're proving identities, it's not very clear. It's not very clear how exactly you would get to the final step, but you just start simplifying things. You start simplifying stuff, and eventually you get to a direction that takes you there. Okay, you improve. With practice, I hope you've done a lot of that. That's how you could do this. Okay, that's part A of this. For binomial, are we supposed to learn about the Pascal triangle? No, that's just one of the ways to derive that formula, but that's not required. That's not required. Okay, Acha, that was part A of this. Let's look at part B now. Now in part B, they're saying, given that secant x is equal to alpha, where x is between 3 pi over 2 and 2 pi, find sine x in terms of alpha. Okay, how do we think about this then? I recently posted, in fact, not recently, just maybe an hour ago or half an hour ago, I posted a video on this as well. If you have one trigonometric function given, how do you find the other trigonometric functions? How do we think about this? We are given that secant x is equal to alpha. First of all, it will make things simpler if you convert it to the base function. So you can say cos alpha. Secant is reciprocal of cos. So if secant x is equal to alpha, then cos x is equal to 1 over alpha. So we've got the value of value of cos x. Now, given cos x, we can find sin x. How do we do that? We have two methods for this. We can use right angle triangles. We can use identities. Both of them will work. But before we do that, let's identify which quadrant x is in. 3 pi over 2 and 2 pi. So between 3 pi over 2 and 2 pi, 3 pi over 2 is here. This is 2 pi. That means we are in the fourth quadrant. And in the fourth quadrant, remember, sine is negative. Cos is positive, but sine is negative. So given the value for cos, can we find sine now? We can use identity, right? We can say sine square x is going to equal 1 minus cos square x. That's 1 minus 1 over alpha whole squared, or just 1 minus alpha squared. Simplify this. This gives you alpha squared minus 1 divided by alpha squared. This is what sine square x is equal to. Take square root on both sides. When you take square root, you get on the right side square root of alpha square minus 1 divided by alpha squared. But remember, whenever we take square root of something, we always put plus minus. But since we are supposed to be in the fourth quadrant, we are supposed to be in the fourth quadrant. In the fourth quadrant, sine is negative. In the fourth quadrant, sine is negative. Since it's negative, we only select the negative sign from here. Okay, and we say sine x is therefore negative square root of alpha square minus 1 divided by alpha. This is one way of writing this. It's not necessary to take LCM here. You could directly put square root on this and put a negative sign. That's also fine because they don't require you to simplify anything. That's your final answer. This is what we wanted. This is sine x, value for sine x. Okay. Any issues with this? With 4a squared equal to 12a? I'm not sure what you want me to explain about that. Did we have that anywhere here? No. Okay. Any issues, anyone? Make sense? The triangle method? In the using the triangle method, you would say cos is 1 over alpha, right? In this case, it might be slightly more complicated, although still not that much. In fact, no, it's pretty straightforward as well. Let me do it using that. On the side here, you still have to figure out the quadrant that we are in the fourth quadrant. So the value of sine is going to be negative. Keep that in mind. You can make a triangle, a right triangle. Cos is 1 over alpha. Cos x is 1 over alpha. Now, cos x is 1 over alpha. How is cos defined? Cos is defined as base over hypotenuse or adjacent over hypotenuse. So in this right angle triangle, we could say if this angle is x, then hypotenuse is alpha, base is 1. Can we find the perpendicular from that? perpendicular squared is going to equal hypotenuse squared minus base squared. And that gives us perpendicular equal to square root minus 1 and then square root of that. Alpha square minus 1 and then square root of that. Now, what about the value of sine x? Sine x is perpendicular over hypotenuse. So we say square root of alpha square minus 1 divided by the hypotenuse, which is alpha. And the same thing we got here as well. Since we are in this fourth quadrant, just put a negative sign with that. And that will be your final answer. Okay. That's how you could use the triangle method. Any issues with this? No problems? Okay, that was question number 10 from this. Okay, there's one more question from this paper. One more question from this paper. Let's do this, and then we move on to the next paper after that. Question number 12. Okay, one last question from this. Question number 12. Okay, this is another one that you want me to do from this. ये देखते हैं. Okay, question number 12. Now they're saying, in this question, n is greater than or equal to 6. Use an algebraic method to show that nc5 minus n minus 1 c5, it can be written as n minus 1 c4. Now, how do we do this? Remember the combination formula that we've got? NCR, that is equal to n factorial divided by n minus r whole factorial into r factorial. Okay? So what we can do is, we can say nc5 minus n minus 1 c5. Let's write them and simplify them. At the same time, simplify this a little as well. And that will give you an idea how to actually prove that this can be written like this. Simplify both of them. Simplify both of them separately and see what you get from them. Let's simplify the first one, NC5. What is NC5? NC5 can be written as n factorial divided by n minus 5 whole factorial into 5 factorial. And then n minus 1 C5, that will be n minus 1 whole factorial divided by, in the denominator, n minus 1 minus 5 whole factorial into 5 factorial. Okay. Now let's simplify this. Let's make the denominators the same. We have n minus 6 whole factorial on the right side. We have n minus 6 whole factorial on the right side. And on the left side, we have n minus 5 whole factorial. Is there a way to take LCM here now? N minus 6, n minus 5 whole factorial, I could write that as n minus 5 into n minus 6 whole factorial, and then we have 5 factorial, minus n minus 1 whole factorial divided by n minus 6 whole factorial into 5 factorial. Okay, this is what we've got. Now, let's take LCM and see what that gives us. The only difference between the denominators is this first fraction also has n minus 5. The second fraction does not have n minus 5. So what I can do for that is, I can multiply the second fraction by n minus 5 as well. Both the numerator and the denominator. And that will give me something like this. N factorial as it is divided by, in fact, I think it will be, yeah, it's okay. Just keep it as it is. So this becomes, the first fraction I can say remains as it is, n minus 5 into n minus 6 whole factorial into 5 factorial. To make the second denominator the same, I'm multiplying both the numerator and the denominator by n minus 5. Okay, in the denominator, I've got n minus 5 into n minus 6 whole factorial into 5 factorial. Okay, now the denominators are both the same, right? So we could simplify the numerators. It becomes n factorial minus n minus 1 whole factorial. This could be written as, if we simplify this further, let's just write it like this first, n factorial minus n minus 1 whole factorial into n minus 5. In the denominator, we have got n minus 5 whole factorial into 5 factorial. This is what we've gotten until this point. Okay? This is what we've gotten until this point. Now what you can do is, both whole factorials will be cancelled. It's not an equation. It's not an equation. So it's not that these are equal to each other, right? There's a minus sign between them. There's a minus sign between them. If it was an equation, we could cancel out on both sides. This is not an equation, right? Achha. Now, it will be a good idea to simplify this a bit as well, because that will give you a hint of what exact form you want to make it now. If you write this down, what is n minus 1c4? N minus 1c4 can be written as n minus 1 whole factorial. And in the denominator, you would have n minus 1 minus 4 whole factorial into 4 factorial. That is what you want in the denominator. So n minus 1 whole factorial divided by n minus 5 whole factorial into 4 factorial. So we want to somehow convert it to that form. That's the plan. If we can somehow convert it to that form, then we could say that's n minus 1c4. We could write it like that. Okay? Now, how do we convert it to that form? That's what we want to do now. The first expression, the first term, n factorial, I could write that first term as n into n minus 1 whole factorial. The reason for that is because now I can take n minus 1 whole factorial common from the numerator. So it becomes n minus 1 whole factorial common. Inside that leaves me with n minus this n plus 5. And that simplifies things a lot now. We've got to that result that we wanted, n minus 1 whole factorial into 5 factorial. 5 factorial as well, what I'll do is, I'll write it as 5 into 4 factorial because we want 4 factorial at the end, right? What we can do is, now we can say in the numerator we have n minus 1 whole factorial. We've got what we wanted there. Into 5. In the denominator, we have n minus 5 whole factorial, which I could write as n minus 1 minus 4. So we can work backwards from there. 5 factorial in the denominator, we could write as 5 into 4 factorial. And there we have it. 5 and 5 get cancelled. N minus 1 whole factorial divided by n minus 5 whole factorial, which we could write as n minus 1 minus 4. Since we are showing this, so it's important to make clear to the examiner the logic that you're using, into 4 factorial. Now you could say this thing is going to be on top of C and this thing is going to be at the bottom. So this can now be written as n minus 1 C4, and that is what they wanted us to show. That was a bit complicated, requires a lot of thinking. Where did n minus 6 go? Where did n minus 6 go? Where exactly? Where exactly? So what I've done is, I actually wrote this together, right? N minus 5 whole factorial, it incorporates this n minus 6 whole factorial. So maybe if I could show it slightly differently. That might make a bit more sense to you. Okay, let me do it this way. So let's not confuse you here. At this step, you could keep it as it is. You could keep it as it is. You could keep it as it is if that is confusing. Keep this as n minus 5 whole factorial. On the right side, all we are doing is we are multiplying and dividing by n minus 5. And when we do that, n minus 5 into n minus 6 factorial, it's like saying we have 10 into 9 factorial. That's the same thing as 10 factorial. So you're basically asking me, where did this 9 go? 10 into 9 factorial is the same thing as 10 factorial, right? So I just wrote that together like that. Okay. Now, in this case, it would be very difficult to figure out what's happening or how to go to that final result unless you first think of what you want at the end as well. Think about what you would need to get in that fraction to be able to get that original form back. So work slightly backwards from the final result, and that will help you understand what you need to do in the next steps. Again, that was not straightforward. That was not very straightforward, required some thinking. And that's how you could do it. How n minus n plus 5 is obtained? I took n minus 1 whole factorial common. I took n minus 1 whole factorial common from both the terms. When I took that common, I'm left with this n minus n minus minus 5, which is plus 5. So I took n minus 1 whole factorial common there, right? From the numerator. That left me with n minus n plus 5. Does that make sense? Okay. That was not straightforward. That was not easy. So it's okay if you take your time to maybe absorb it. Can go through the working again. Let's move on to the next paper. Yeah, it is a bit confusing. It is a bit confusing. There could be multiple ways of doing this as well. But I think you won't find something that's very efficient, as in maybe a couple of steps could be reduced here. But most of this working will need to be done. ठीक है. Acha. Let's do another one now. Okay, that's it from this paper. That's it from this paper. From the next paper now, there's only one question that you guys asked about. That is question number 9. Is that correct? Question number 9. Yeah. So from the next paper, you have only asked about question number 9. Let's do that now. Let's move on to the next paper. The next paper is June 2025, paper 1-2. June 25, paper 1-2. Let me copy that question here. Question 9. Okay, that has a lot of parts. Okay, chale, let's do this now. It has 4 parts, this question. Let's try this. Okay, so it's given that this is June 25, paper 1-2, question number 9 from this. When will the stream end? I think in about 50 to 60 minutes, around 10:40 type, most likely. because we will be doing difficult questions from one more paper. So I think 3-4 more questions after this, or maybe 5 questions, depending on, let me see. So this is one question that we're doing. Then from the next paper, we just have, no, yeah, we have 4 questions from the next paper. So 5 more questions to go. 5 more questions to go. Okay, चलिए. It's given that this function 2 ln of 3x minus 4, this is defined for x greater than a, and it's given that f inverse exists. All right, now it's a log function. Remember, log function is always a one-to-one function. Log function is a one-to-one function, right? What's the least possible value of a? Is there a restriction for the values of x that we can input? Remember, log is only defined for positive values. So all you have to do is you say the part that is inside the brackets, that has to be greater than 0. The part inside the bracket has to be greater than 0. So 3x minus 4 has to be greater than 0, and that tells us that x is greater than 4 over 3. Okay, so what's the least possible value of a then? The domain of that function, you would say the least possible value of a, that is 4 over 3. Right, so in this place, in place of a, the minimum possible value that you could input is 4 over 3, and that's your final answer. ठीक है. अच्छा. Now they're saying for the value of a that you found, find the range of f. Okay. Remember, this function is a one-to-one function. Log function, exponential function, they're both one-to-one functions. For one-to-one functions, the range can be just found by looking at what happens at the end points. Okay, just see what happens at the end points. What happens if a is close to 4 over 3? So think about what happens when it's close to 4 over 3. F of x is equal to 2 ln of 3x minus 4. That's the function, right? Can we input 4 over 3 exact in this function? No, because that will give us ln of 0, right? But we can input some a value which is very close to 0, like 0.00001. You know what happens when that is the case? Okay, I'm sorry, not 0.001. So very close to 4 over 3. So essentially what happens is the number inside log is supposed to be very close to 0. So something like this, 2 ln of 0.0000001. Remember, we have an asymptote at x equal to 0. So when it reaches the asymptote, what happens to the function is this log function, it is going to be like this. Close to the asymptote, it is going to be going towards negative infinity. So when the number inside log is extremely small, this value actually approaches negative infinity. So on one side, it's going to approach negative infinity, okay? What about the other side? If x becomes extremely large, how large? It could go up to infinity. So on the right side, remember the log function, it just keeps going up and up and up. There's no horizontal asymptote. It just keeps going up like this. There's no end to that as well. So vertically, on the left side, it could go down as far down as possible. On the right side, it can keep going up. It never reaches some maximum point. It keeps going up like this. So there's no limit. There is no limit. For a log function, asymptote is always vertical. For a log function, you always have a vertical asymptote. For exponential function, you have horizontal asymptotes. So there's no end to the graph. There's no end to the graph. So in fact, there's no calculation needed as well in this case. Just think of the graph, in fact. That will be easier. This is what the graph looks like. We're looking at the whole domain. There's no lower limit. There's no upper limit. So you could just say the range for that reason for this graph is just going to be all real values. Y belongs to all real values. There's no limit in this case. Right? It's the same for exponential function. If the whole function is valid, then the range is just all real numbers. There's no restriction on that. Okay. Exponential functions have horizontal asymptotes. Exponential functions have horizontal asymptotes. Log functions have vertical asymptotes. Okay, you need to remember that. Achana, what about the inverse function? Inverse of a log function. Inverse of a log function, what would that be? F of x equals 2ln of 3x minus 4. How do you find inverse? We can say let y equals f of x. That gives us y equal to 2ln of 3x minus 4. Make x the subject. That gives you y over 2 equal to ln of 3x minus 4. What's the base of ln? Base of ln is e, right? E will go to the other side, become the base of this number in power form. And that gives us e raised to the power y over 2, that equals 3x minus 4. 4 goes to the other side. We get e raised to the power y over 2 plus 4 equal to 3x. Divide by 3 on the other side, and that gives you e raised to the power y over 2 divided by 3. Or you could just put the whole thing plus 4 whole divided by 3. What's the inverse function going to be then? Switch the variables. F inverse of x, that is e raised to the power x over 2 plus 4 divided by 3. That's an expression that we've got for f inverse, and that is what we wanted to find out there. Okay, that's the f inverse function. Okay. That was straightforward, the second part. Let's look at the next one now. Okay, now they're saying it's given that the equation f of x equals f inverse of x has two roots. Okay, f of x and f inverse of x, they have two roots. Remember, when do the graphs of a function and its inverse, they meet each other? A function and its inverse, where do they intersect? They only intersect at y equals x line, right? If it has two roots, there are 2 points of intersection. There are 2 points of intersection with the line y equal to x, because a function and its inverse, they always intersect at the line y equals x. Achana, what they want us to do is, for our value of a, that was 4 over 3, right? Sketch the graphs of y equals f of x and y equals f inverse of x on the axes. Label each graph, state the intercepts of each graph with the axes. State the equations of any asymptotes. That's a 4-mark question. Okay, how do we think about this now? The original function that we're given, that is y equals 2ln of 3x minus 4, right? 2ln of 3x minus 4. That's the function. Now for the log function, do we know how to find the asymptote? The asymptote is when this part inside the bracket that is equal to 0. That is where the vertical asymptote is going to be. So that's 3x minus 4 equal to 0. The value of x that we get from that is 4 over 3. For the log graph, that's the asymptote. It's a vertical line at 4 over 3. Let's draw that line here. Let's say this is the point 4 over 3 maybe. X equals 4 over 3. That's the asymptote for the log graph. How is the graph going to look like? We also have to state the intercepts with the axes, right? It's not intersecting with the y-axis, of course, if this is the asymptote. What about the x-intercept? Can we find the x-intercept as well? Put y equal to 0. 2ln of 3x minus 4. 2 goes to the other side, gets eliminated. And then we could say e raised to power 0, that is equal to 3x minus 4. E power 0 is 1. So we have 1 equal to 3x minus 4. And the value of x that we get from this is 5 over 3. So that tells us the point where this graph is going to intersect with the vertical axis is 5 over 3. So at 5 over 3, this log graph intersects the x-axis. Now, can we just sketch that graph now? We've got this point at 5 over 3. It's a simple log function. There's no transformation that's happening. There's no minus sign multiplying outside. There's no minus sign with x. So it's the standard log graph like this. You can make that shape. Let's make the asymptote dotted. That's how you should do it. On the left side, it's going to go like this. Towards negative infinity on the right side, you know the shape of the log graph is going to be like this. That's one graph. You have to label that. Label that graph. Y equals ln of 3x minus 4. Now, whenever you draw the graph of a function and its inverse, you always draw the y equals x line as well because it's supposed to be a reflection in that line. Okay, we also have to keep this in mind, right? It has two roots. They told us that it has two roots, so there should be 2 points of intersection with line y equals x. So let's make the line y equals x, and I'll just change the graph slightly on this side then. So it intersects at 2 points. Let's make that line first of all as well, y equals x line. So it might look something like this. Y equals x line, 45-degree line roughly. Draw that here. This is y equals x line, the line of reflection of that function and its inverse. We draw that here as well. Y equals x. Now the log graph, it has to intersect at 2 points with the line y equals x. So keep that in mind. So something like this. You could draw your graph like this. ठीक है. This is what we had to do. Now, the exponential graph, what is that going to look like? It's going way outside the available space that we have actually. Could we make it intersect slightly below somehow? Y equals x. This graph is a bit distorted. Generally, we have to take the same scale on both axes. So let's just keep it as it is. You'll get the idea. So it's intersecting at 2 points. Keep that in mind. These are the 2 points of intersection. Achha, now what about the exponential graph? What about the exponential graph? Now there are two ways of sketching the exponential graph. You could either think of it from this exponential function. What's the asymptote of this graph? You break it down into two parts, 1 over 3 into e raised to power x over 2 plus 4 over 3. This number that's being added outside, that's the asymptote of this graph. Or you could also say, since it's the inverse of this, if the log graph has this asymptote, the exponential graph is just going to have the same asymptote with y being equal to 4 over 3. So you can draw that line now, y equal to 4 over 3. Now, where is that line going to be? Let's suppose it is here. This is 4 over 3. Let's draw this horizontal line at 4 over 3. Now, see, this asymptote is also going to intersect at y equals x because it's the same x and y value at both of those points. So the asymptotes are going to intersect at y equals x line as well. You can label this as y equals 4 over 3. That's the asymptote of the exponential function. Now, what's the exponential function going to look like? Again, for the exponential function as well, you can see there's no transformation happening, right? As in, there's no reflection happening. There is a transformation, yes. I mean reflection. There's no reflection happening. So the shape is going to be the standard exponential function. There's no negative sign multiplying outside. There's no negative sign with x, right? So we draw that shape now from this. Now, how exactly do we draw that shape? Its intersection with the vertical axis. Where is that going to be? Y-intercept. The x-intercept for the log graph was this. Y-intercept for the exponential graph would be at 5 over 3. So the graph is going to look something like this now. It is going to go like this on the left side. And it's going to have these 2 points of intersection. So something like this. On the left side, it will go like this. Here, then become almost horizontal like this on the left side. That looks a bit weird on that side. I'll try to correct that slightly. It's pretty time taking, these graphs. I generally recommend A-level students as well to leave these for the end of the paper because they end up taking a lot of time and they're not worth it for the marks that they have. If you end up missing out on some other question because of this. Although you don't have that problem generally a lot in admaths if you know your stuff. That's the exponential graph, not a very nice looking graph. Try to maybe make it slightly smoother, but you get the idea, right? Label this. This is f inverse of x. This original graph. This was f of x. Is that okay to everyone? Let me know now if there are any specific questions. For log graph, we have vertical asymptote. For exponential graph, we have horizontal asymptote. ठीक है. Makes sense? Do we move on now? Acha, from this paper, we only had this question that a lot of you voted for. Let's move on to the next one. From this paper, now we have 4 questions. If I remember correctly, let me look at the poll again. Yeah. So from this last paper, we have questions 9, 10, 11, and 12. June 25, paper 1-3. Let's look at a couple of questions from this now. Not a couple, in fact, 4 questions from this. Question number 9, 10, 11, and 12. Yeah. Okay, let's do this. 9, 10, 11, 12. Okay, it has a lot of parts. Okay, the rest of the parts as well. It looks similar to what we've just done, this sketching part. I think it's easier than the one that we just did. Okay, just last part, and then we start part 3 as well. Okay, Charan, let's start with this. Question number 9 from this paper. The function f is defined by this for x between 0 and 3. Express f of x in this form. We have to complete the square, right? There are multiple ways of doing this. This is the method that I generally prefer, that we find the x and y coordinates of the turning point minus b over 2a, or differentiation. What's the turning point going to be? Minus 9 over 2 into minus 2. The turning point, the value for h in this vertex form or the completed square form, the value for h is 9 over 4. Okay, now once we got the value for h, let's find the value for k. Input it back in the function, the y coordinate of the turning point, it will be minus 2 into 9 over 4 whole squared plus 9 into 9 over 4 minus 10. Now we have to simplify this because calculator is not allowed. What do we get? Minus 2 into 81 over 16 plus 81 over 4 minus 10. We can do some cancellation. 16 and 2, they get cancelled to give us 8 in the denominator. If we take LCM, minus 81 over 8 plus 81 times 2 is 162. 162 divided by 8. 10 times 8 is 80. So we can say that's 80 over 8. What does that simplify to? Minus 162 minus 81 minus 80. That will just leave us with 1 over 8. That's the value for k that we've got. That's the y coordinate of the turning point. Once we've got the x and y coordinates, just input values in that now. A is going to be the same as this here, which is -2. So we get f of x equal to minus 2 times x minus h, that means x minus 9 over 4 whole squared, plus k, the value for k is 1 over 8. That's what we wanted. They wanted us to write it in this form with constant written first. So you can say 1 over 8 minus 2 into x minus 9 over 4 whole squared. That's the function that we wanted to find. Okay. In the calculator paper, you could actually do it in just one single step. You can find the turning point from the calculator directly and then just write down the answer. Because in completing square questions, you generally have the marks only for the final answer. Okay. So as long as the answer is correct, that is sufficient. Part 2 now. Now they're saying hence determine whether or not f inverse exists. Now where is the turning point? Where is the turning point? The turning point is at x equal to 9 over 4. Turning point is at x equal to 9 over 4. X coordinate of turning point. That is 9 over 4, which is 2.25, right? What kind of graph is this? It's a quadratic function. It's an N-shaped graph, inverted U. So like this. This is the shape of the graph. Okay? This is the shape of the graph. If the turning point is in that domain that we're given, from 0 to 3, that's the domain, right? So let's suppose we've got 0 here, we've got 3 here. Turning point is in the middle. This function is not going to be a one-to-one function, right? If turning point is not in the given domain, then that means it is going to be a one-to-one function. So what do we say then? We can say turning point is between 0 and 3, the domain that is given, which means it's not a one-to-one function. It's not a one-to-one function. And that implies that f inverse does not exist. Now, what do you have to write down in the exam? Write down that the turning point is between 0 and 3. That's one statement. And then since it's not a one-to-one function, inverse does not exist. You have to give the reasoning for this as well. It's a 2-mark question. If it's a 1-mark question, generally it's enough to just say it's not one-to-one. But it's a 2-mark question, you have to give reasoning for that as well. Why is it not a one-to-one function? Because turning point is in the middle. If turning point is in the middle, then it is not. Yeah, so instead of one-to-one, instead of writing one-to-one, you could also say it fails the horizontal line test. If you draw a horizontal line, it may pass through more than one point. That is why inverse does not exist. That's also fine. But you have to mention turning point because that is how you determine whether it is going to be one-to-one or not in this case. Okay. For horizontal line test as well, you'll have to use the turning point. Acha, B1, let's do that. We have just done this already in the previous paper as well. This is actually easier because they just want you to sketch this one graph now. Find the asymptote. Where is the asymptote going to be when 5 minus 2x is equal to 0, right? That gives us x equals 5 over 2. So there might be x equals 5 over 2 here, let's say. You have an asymptote here. Make a dotted line there. Vertical asymptote. What about the intercepts? Put y equal to 0. You get 0 equal to 3 ln of 5 minus 2x. 3 goes to the other side, gets eliminated. E power 0, that equals 5 minus 2x, and then 2x equals 5 minus 1, which is 4x equals 2. The x-intercept turns out to be x equals 2. 2 will be on the left side here. This is the x-intercept. Okay, now what does the graph look like? It is ln of 5 minus 2x. 5 minus 2x. Sure. Now, this is one point. Close to the asymptote now, it is either going to go above, go in the upward direction, or go in the downward direction, right? One of these things is going to happen. What we can do is we can find the x-intercept as well. Sorry, y-intercept as well, because they require us to do that. And that will tell us the shape of the graph then. Let's find the y-intercept as well. Put x equal to 0 for that. That will give us y equal to 3 ln of 5 minus 0. So that's 3 ln 5. So on the vertical axis, you can mark some point 3 ln 5. That's a positive number, right? Let's suppose that is maybe here somewhere. Let's mark that point as 3 ln 5. That's your y-intercept. And now you can make that shape of the standard log graph. You can clearly see it's going to go towards negative infinity on this side. So it goes like this. On the other side, it slowly keeps going up like this. And that's the graph that you draw there. Okay. Makes sense. Acha, sorry. So the domain says from 0 to 2.5. So we don't have to extend the graph. We don't have to extend the graph. We can remove the part on the left side. Yeah, just this much. This is sufficient. ठीक है. Makes sense, right? Chale, let's move on. That was B1. Now they're saying find an expression for G inverse of X. G inverse of X. What about this now? G inverse. We've got the function. Again, that's very similar to what we've just done in the previous question as well. G of X equals 3 ln of 5 minus 2x. The domain of this function is from 0 to 2.5. ठीक है. अच्छा. Now, what about the inverse function? We can say let y equals g of x. Y equals 3 ln of 5 minus 2x. Make x the subject. Y over 3. That equals ln of 5 minus 2x. Base of ln is e. It goes to the other side, becomes e raised to power y over 3 equal to 5 minus 2x. 2x equals 5 minus e raised to power y over 3, and x equals 5 minus e raised to power y over 3 divided by 2. Interchange the variables and you get G inverse. G inverse of x, that equals 5 minus e raised to power x over 3 divided by 2. That's the inverse function. And that's our final answer. ठीक है. चलिए, let's move on now. Find the domain and range of G inverse. Give each of your answers in exact form. Now, what about domain and range of the inverse function? Remember, if we have the domain and range of the original function, we can use them to find the domain and range of the inverse function. For the original function, for example, how do I write it? Yeah, I think it's okay. What's the domain of the original function? What's the domain of the original function? Domain of the original function is x between 0 and 2.5. And it's written like this, 0 and 2.5. The range of the inverse function, therefore, is also going to be between 0 and 2.5. All you have to do is replace x with y. That's the range. What about the range of the original function? What's the range of the original function? You've actually sketched the graph before. You can just look at the graph and write down the range based on that. You can see the maximum point in that interval from 0 to 2.5, that is at 3ln5. You already found that. What's the minimum point? It's going up to infinity, negative infinity. So range is anything below 3ln5 or equal to 3ln5. So we could say for the original function, the range would be y less than or equal to 3ln5. That is going to be the domain of the inverse function, and that is x less than or equal to 3ln5. And that's what you wanted to write down. This is what they were asking about. Okay? For inverse functions, domain of the original function is range of inverse. The range of the original function is domain of the inverse, and that's the final result. Okay, that was question number 9. Let's move on to the next one now. Okay, next one that you asked about from this paper is question number 10. Let's do that. Question number 10. Let me copy this one now. Okay, so now we've got a vectors question. All right, chale, let's try this. We have this diagram that shows 4 points. This diagram shows 4 points O, A, B, and C. A, B, and C lie on a straight line such that AB over AC is 1 over 3. Okay, A, B, and C. Okay, so you can see that they lie on a straight line. AB and AC ratio, AB and AC ratio. That means if this is one part, if this is 1 unit, then this is 2 units, right? Because the whole thing is 3 units. So we've got the ratio given. First of all, they're saying find OC vector. Okay, OC vector, we could say on that diagram, we could go from O to A and then from A to C. Now, OA is known, that is just A. Let's just keep it as it is for now. AC, however, that we can say is 3 times AB, right? AC vector is 3 times AB vector given this ratio. So we could write this as 3 times AB. Now, AB we can find easily. We can say OA vector plus 3 into OB minus OA. And that simplifies to A plus 3 into B minus A, because OA was A, OB was B. And that finally simplifies to A minus 3A, which is minus 2A plus 3B. That's the vector OC. The first part is extremely straightforward. That's 3 marks. Easy 3 marks. Okay. That was 10 part A. Now they're saying the line OA is extended. Okay, line O is extended to the point D such that OA ratio AD is 2 over 7. I often like to write these ratios in fraction form. That simplifies things a little. OA over AD, that is 2 over 7. Okay. OA is extended. Now it'll help if you just draw it here. If OA is 2 units, then AD is 7 units. So there's a point far away from A. So just extend this. Use a ruler for this. That will make it easier to understand what's happening. So maybe here somewhere you have this point D. Take it. And this point is such that if this is 2 units, or let's call this 2 parts, then this is 7 parts. In total, that's 9 parts. Okay. All right, that is one piece of information that's given now. Point E lies on CD. such that OE vector is lambda b. Okay, there is a point on CD. If we were to join C and D, there is a point on this line CD such that OE vector is lambda times B. Acha, OE is lambda times B. What that means is it is a multiple of B. So there's a point E somewhere. Where exactly is that point E going to be? It is going to be on this OB line extended, right? Because it's a multiple of B. So its OE vector is going to be parallel to OB in the same direction. So this point E is going to be right here. That's how it looks like on the diagram. Okay. So it will be a good idea to draw this diagram. That will make it much easier to understand what's happening. Okay. So we are given OE vector is lambda B. What we're looking for is the value of lambda now. Okay. OE vector is lambda times B. That is one thing that we're given. We have this ratio. If we write it like this, we could say OA. Since OA and AD are in the same direction, if we have two parallel vectors and there's some ratio between their lengths, the ratio of their vectors is going to be the same as well. So we can say OA vector is basically, in fact, OA we already know. Let's make AD the subject. I could say AD vector is equal to 7 over 2 times OA. Okay. AD vector is 7 over 2 times OA. Achha, that's the information. We have to find the value for lambda. Achha, lambda is in the vector OE. Can we find the vector OE somehow? Can you find the vector OE somehow? Let's think about it. So starting from O, can we get to the point E using some path that we know? We could go from O to D, but we don't know what OD is. And then from D to E, we don't know what that is as well. We have okay, we have found OC in the first part. We have found OC in the first part. We could perhaps use that. We can find OD because OA is this, AD is this. Okay, chale. Let's think of it this way. Let's think of it this way. If this is 2 parts, this is 7 parts. What about the total thing? What about the total thing? That will be 9 parts, right? So in total, that will be 9 parts. So we could say the vector OD. Vector OD. What is that going to be? 9 over 2 times OA, right? If this is 2 parts, the whole thing is 9 parts. So it's kind of multiplied by 9 over 2 or 4.5. So that's 9 over 2 times OA. So OD vector turns out to be 9 over 2 times A. That's OD vector. Okay. Acha, once we've got OD, we already know OC as well. We already know OC as well. OC vector is equal to minus 2A plus 3B. Using these two, what we can do is we can figure out the vector CD. And then we could somehow find CE from that as well. Let's do that. Let's actually find CD first, see what that turns out to be. CD vector. What's CD? CD is OD minus OC. That will be 9 over 2A minus minus 2A. That becomes plus 2A minus 3B. Simplify this. That gives us 13 over 2 times A minus 3B. That's the vector CD that we're getting. Okay. So we found the vector CD. We found the vector CD. Now, since we already know OC, we already know OC, we could say let's go from O to C and then from C to E. OC is already known. CE, we could say, since it lies on the line CD, it will be in the same direction as CE. So what I'm going to do for that is I'm going to say OE vector, or before that, let's write CE vector. CE vector, CE vector is in the same direction as CD vector. So CE we could say is K times CD. CE vector is K times CD, right? Because it's in the same direction. CE direction and CD direction, they're both the same. So they're both parallel to each other. So we can say it's K times that. And now we could figure out the vector OE from this. We could say OE is equal to, one possible path that we could follow could be we could go from O to C and then from C to E. So OC plus CE. What do we get from that? OC plus CE. OC plus CE. OC turns out to be minus 2A plus 3B. And CE can be written as K times CD. CD is 13 over 2A minus 3B. So we've got that vector OE now in terms of K. Let's simplify this and see what that gives us. Minus 2A plus 3B plus 13 over 2 times Ka minus 3Kb. Write the A components together, minus 2 plus 13 over 2 times K whole times A plus 3B minus this. We could say that is 3 minus 3K whole times B. This is what we're getting. Won't it be CE? CE. What exactly? Let me check again. CE is equal to K times CD. Are you saying this must be CE? I'm saying I'm finding the vector OE, right? I'm going from O to E. We can say OC plus CE. And then C is the same thing as K times CD. That's what I'm inputting here. Okay, maybe I'll answer your question at the end. Let's complete this first. If it's still confusing, let me know. Acha, this is what we're getting for OE. In the question they said, OE vector is supposed to be lambda B. OE vector is equal to lambda B. So there's no A component in that. So we could say it's 0A plus lambda B. And now we can compare both of them, right? Because we are getting this OE, they gave us this OE. So they should match each other. They should match each other. Okay. So the A components, they should be equal. So the A component, it has to be 0. And the B components should also be equal. So lambda should equal 3 minus 3K. Now, what do we get from that? We get minus 2 plus 13 over 2 times K. That equals 0. And 3 minus 3K equals lambda. What's the value of K that I'm getting from this? 13 over 2, K equals 2. And K equals 4 over 13. That's the value of K that I'm getting. Input that in the other equation, and that gives me 3 minus 3 into 4 over 13. That equals lambda. That's 3 times 13, that will be 39. If I take LCM, minus 12 divided by 13, and lambda turns out to be 27. 27 over 30. That's the value that I'm getting for lambda. And that's your final answer. That was pretty complicated. If you end up starting this in the middle of the exam, that'll destroy your confidence. So it's towards the end. That's a good thing. But I think a lot of people would spend too much time on a question like this, and then they could lose easy marks maybe if the questions 11, 12, 13, they are relatively easier. It was pretty complicated. That's how you could do it. Let me know if there's any question now. It won't matter, the answer is the same. He meant to say that CD equal to K times C. Okay, if that's what you're saying, that's also fine. CD is equal to K times C. That will also work, of course. The value of K in that case would turn out to be 13/4. Just reciprocal of this. Doesn't matter. The value of lambda at the end, that will remain the same. You can also do it that way. That's also fine. Does this make sense? Any questions on this? This was quite complicated, to be honest. So a very important thing for the exam tomorrow, make sure that you are not getting stuck at any question in the middle of the exam. Make sure that you do all the questions that you can easily figure out first. And then at the end, when you have any time left, you come back to the questions that you were not able to figure out and do them. So ideally, if you're well prepared, you should be able to do around maybe 9, 10 questions in the first go. There might be some parts that you are not able to do, but then the rest of them you would do in the second pass then. Okay, so you don't miss out on any easy marks on the paper. Okay, chale. Let's look at the next one. That was question number 10. Next is question number 11. Wait, just give me a second. I need to leave a message. Okay, chale. This was part A. Which topics should you focus on revising right now? Anything that you have not revised in the last couple of days, you should definitely revise that. Do not skip any topic, but some topics in which you might need to revise a bit more, you would say functions, because that has a lot of detail. And then if you don't remember asymptotes of some graphs, make sure to go through that exponential graph, log graph. They're coming repeatedly in recent papers. And then look at some circle equation questions in the recent papers, last 2, 3 sessions since it was added to the syllabus. Make sure that you go through them. Some integration questions that have been coming in the recent papers where they ask you to integrate a product, go through that specifically as well. These permutations and combination questions where you have to use the formulas NCR equals n factorial over n minus r whole factorial, r factorial, and also for permutation. Make sure to go through those concepts as well. But ideally, revise everything. Just skim through everything quickly, all of your notes. It doesn't take a lot of time. And after that, make sure that you have good night's sleep. That is also important. Achha. At time t seconds, displacement from O is given by this. P is moving in a straight line. Okay. So for t between 3 and k, the velocity of P is positive and its acceleration is negative. Okay. So acceleration, remember, in a velocity time graph that they want you to sketch, It represents the gradient. Gradient is negative, but velocity is positive. That means it's above the x-axis with a negative gradient. Okay. Now, we need to sketch. They have also given us the maximum velocity of P occurs when t is equal to 2. On the axis below, sketch a velocity time graph for the first k seconds of the motion of P. All right, so we have a cubic function first up. That is valid from 0 to 3. That's valid from 0 to 3. Okay, we can mark 3 somewhere on the graph. Let's suppose maybe 3 is here. And then from 3 to k, we have this quadratic function that is valid. Now, they have told us the maximum velocity of P occurs when time is equal to 2. At time equal to 2, can we figure out that maximum velocity? This is the displacement function, right? Can we find the velocity function from this? Differentiate it. You get 1 plus 12t minus 3t squared. So it's a quadratic function. Minus 3t squared plus 2, 12t plus 1. Put time equal to 2 in this and see what value of velocity you get. V equals minus 3 into 2 squared plus 12 into 2 plus 1. What do we get from this? Minus 3 times 4 is minus 12. Minus 12 plus 24 plus 1. I think that's 15, right? Or 13. Let me just write that down. Minus 12 plus 24 plus 1, which will be 13. Okay, so we know at time 2, we have a maximum velocity. And the value of that maximum velocity is 13. Let's mark that there. So we have a maximum point here. Okay. Now, what's the velocity at time 0? If we put time equal to 0 in this, if we put time equal to 0, what's the velocity value that we get? At time 0, 1. So we know that this point is going to be 1 here. So the graph looks like this. It's an N-shaped graph, right? The coefficient of this square term is negative, so it's going to look like this on the left side. And then after that, at the point 3, let's figure out what the velocity is at the point 3. I would recommend, if it's easy to calculate the velocity numbers, you do calculate them. Sometimes they will expect you to have calculated them. Sometimes they will not have it in the marking scheme. So it's always a good idea, if it's easy to figure out, if it's easy to calculate the velocity values for the maximum point and at the point 3 at the important points, do that if it doesn't take a lot of time. Okay, so in this case, it's not going to take a lot of time if you do calculate those velocities. Let's calculate it at 3 as well. Minus 3 into 3 squared plus 12 into 3 plus 1. What does that give us? Minus 27 plus 36 plus 1, which is 10. So at 3, the velocity number is 10. Let's suppose this point is 10 here. So it comes down a bit like this. Let's say what I'll do is maintain symmetry of the graph. I will bring 3 slightly closer. So this is 2, this may be 3 somewhere. Okay, so that's how the graph looks like for the quadratic part. Once you have drawn that quadratic part, what do we do next now? Draw this part now. This is going to be a straight line. This is going to be a straight line, right? Velocity function for this. Find the derivative. 12 minus 2 over 3 times t. That's the velocity function that we've got. Now it's starting from 12 at time 0. At time 3, it should be the same number here, which is 10. From this point onward, what we have is a straight line. Up to when? Up to this point k. Now they told us the velocity is positive up to k. So we are not going to touch the graph with 0. because it remains positive, the velocity, we're going to keep it at some positive number here. Okay, it may be here, here. We don't know what the actual number is, but we're going to keep it positive. So do not make it touch the x-axis or take below the x-axis. They told us velocity remains positive. So maybe some point above the x-axis here. And that's what the velocity function looks like. The first part is for the quadratic function. The next part is for the linear function. Is that okay? Okay. How to draw graphs for the log graphs, how to know whether it's negative. Just remember the asymptote of the log graph. Asymptote is when this part inside the bracket is equal to 0. For an exponential function, the asymptote is you have anything in terms of x here. For exponential function, the asymptote is this thing. For log function, you put this equal to 0. That will give you x equals something. For exponential function, the number that you've got here, that's the horizontal asymptote. Okay. Then you find the x-intercept, y-intercept, and make a graph based on that. Now, full explanation of that is going to take time. Remember the shapes of the graph. These are the 4 possible shapes of exponential and log graphs. For exponential graph, we have horizontal asymptotes. For log graphs, we have vertical asymptotes. Okay. Achha, let's look at the next part now. Let's look at the next part, part B. Okay, now they're saying the total distance traveled by P for time between 0 and K is 57 meters. Given that T is equal to 3, when T is equal to 3, the distance and displacement of P from O are equal. Find the value of K. Okay. It passes through a fixed point. At T seconds, its displacement from O is given by this function. Okay, how do you find the value of K? How do you find the value of K? We could say it's a velocity time graph. Distance traveled or displacement of the graph is given by the area under the graph. Find the area under the graph from 0 to 3 for the quadratic part. Find this area. Add to that the area of this trapezium that you have on the right side. Equate it to 57. Equate it to 57. Okay. In this case, distance and displacement are going to be the same, right? Distance and displacement, they're both going to be the same because velocity is positive throughout. Velocity is positive throughout. Since velocity is positive throughout, distance and displacement, they are going to be equal to each other. Okay. Achha. Now, in fact, we've got the displacement function already, so we can actually use that directly. So we don't even have to use integration. We could do that directly from there. Use this displacement function to find the displacement at the point 3. They told us that this displacement and distance are the same in the first 3 seconds. So we've got the displacement function for the first part of the journey. What is that? Displacement for first part of the journey. That is given by t plus 6t squared minus t cubed. Input time equal to 3 in this. You get 3 plus 6 into 3 squared minus 3 cubed. Now, what do we get from that? 3 plus 6 times 4, that is 6 times 9, that is 54 minus 27. What does that give us? 57 minus 27, that's 30. So in the first 3 seconds, the distance traveled is 30 meters. Now they have told us that the distance and displacement are equal, although it wasn't really required in this question because we have drawn the graph already As long as you have calculated these values, they have probably given this information for those who have not calculated these values. We can see on the graph, the velocity is always positive. If the velocity is always positive, distance and displacement are both going to be the same. They have different values only when the direction of the object changes, right? In this case, the object is not changing direction, so the distance and displacement are going to be the same values. Achha, now this is the distance traveled for the first part of the journey. This we figured out is 30 meters. Now, what about the next part of the journey? This part of the journey. We can use area of trapezium formula for that. What's the area of this trapezium? We already figured out this value is 10, right? Now we need to calculate that anyway if we have not done that previously. The problem is we don't know uh, this point here, what the height of the graph is at this point. Okay. We don't know the height of the graph at this point. So they have given the total distance traveled, that is 57 meters. So the area of this part has to be 57. That's what we know. Area of this part has to be 57. Did they give us any other information? They just told us acceleration is negative. Okay, let's just try. What's the area of this part going to be? Let's find the area of that trapezium. What's the area of trapezium going to be? 57 minus 30? Why 57 minus 30? Why would it be 57 minus 30? It's 27, right? 3 plus 54, that's 57. Minus 27, that's 30, right? Okay, achha. What about the area of the trapezium? Area of the trapezium plus this 30 that we have calculated here, this should equal 57. Okay, because that's the total distance traveled. It should be 57. Now, what's the area of the trapezium? Half into sum of parallel sides. Now, one parallel side is 10, that we know. The problem is the other parallel side, we don't know what this height is. We can think about something for that. Let's leave it as it is. What about the height of the trapezium? It's k minus 3, right? This distance is k minus 3. So height of the trapezium is k minus 3. Plus 30, we could take that to the other side. 57 minus 30, that is 27. Now the problem is, how do you find this parallel side? It's a straight line. It's a straight line. We know the function for that, the velocity function. The velocity function was v equal to 12 minus 2 over 3 times t. Right? That was the velocity function. What we can do is, we can say, when time is equal to k, when time is equal to k, at that particular time, what's the velocity value going to be? 12 minus 2 over 3 times k. So the height of this point, this parallel side, its length is going to be 12 minus 2 over 3 times k. That's what we can input there. That's the other parallel side. 12 minus 2 over 3 times k. Now you solve this equation and that will give you the value of k. You can use limits. You're actually right. If you use limits, you already have the displacement function. You're actually right. Let's do that. So trapezium will be slightly difficult. But now that we've done this, we can actually continue like this as well, and that's okay. But you're right. If you use limits instead, that will be easier to think of. 2 goes to the other side, that's 54. You can solve this equation further, and that will give you the value for k. Now, what I'll do is, I'll take it to the side, and I'll take your suggestion. You're right. Limits would make it easier because we won't have to find the height of the trapezium then. Let's do that. We could also do it using limits. We can also do this using limits. So for the first part of the journey, we know that displacement is 30 meters. For the next part now, the displacement has to be 27. So we could say that orange part, that displacement for time between 3 and k. Let's figure out what that displacement turns out to be. Let's call this first displacement S1. What about the second displacement? We already have the displacement function. Input limits in that. Input limits from 3 to k. So the displacement function is 12t minus t squared over 3 minus 3. Input limits in this from 3 to k. Okay. And that will give the displacement for the second part of the journey. So that becomes 12k minus k squared over 3 minus 3. Subtract from this the case when you input time equal to 3. That's 12 times 3 minus 3 squared over 3 minus 3. So yeah, that is simpler than calculating areas. That requires more thinking. Simplify this now. This becomes 12k minus k squared over 3 minus 3 minus 36 plus 3 minus 3. That becomes plus 3 as well. Let's simplify. This gives me 3 and 3 get cancelled. Minus 33. 12k minus k squared over 3 minus 33. That's the second part of the displacement. Okay, we've got the second part of the displacement. Now they told us the total distance traveled is 57. The total displacement is the same as distance traveled in this case because velocity is positive throughout. We can just add these two numbers now, equate it to 57. 30 plus 12k minus k squared over 3 minus 33 equal to 0. Multiply the whole equation by 3 to simplify this. Before that, I will do one more step. 30 minus 33, that's minus 3. Multiply the whole equation by 3 and that will give me 36k minus k squared minus 9 equal to 0. Multiply by negative 1 to make the square term positive, and that becomes k squared minus 36k plus 9 equal to 0. Now, can we factorize this? By adding them, they want us to find the value of k. There's only one value of k that we're supposed to get. Can we factorize this, by the way? We can't factorize this, right? Let me just check my working again. 3 to k, the displacement function 12t minus t squared over 3 minus 3. Okay, right. These were the limits from 3 to k. Okay, because often in the first part, in the quadratic equations in paper 1, they give you equations that can be factorized. Otherwise, they mention find exact value if you have to use quadratic formula. So let's just check in case our working is correct. Otherwise, we'll just use the quadratic formula. 12k minus k squared over 3 minus 3 minus 12 into 3 minus 3 squared over 3 minus 3. That looks okay. 3 and 3 get cancelled. Minus 36 plus 3 plus 3. Can anyone spot any careless mistake anywhere? 30 plus 12k minus k squared over 3 minus 33 equals 0. It'll be equal to 27? No, because I added 30. Oh yeah, sorry. So on the right side, yeah, so that's the problem. Achha, so now that we found the two displacements, S1 is equal to 30, S2 is equal to this, we were told that the total displacement is 57. So we equate this number to 57. We equate this number to 57. Yeah, it should be 57. So now simplify this. This gives me 12k minus k squared over 3 minus k squared over 3 minus 3 equal to 57. Multiply the whole equation by 3 now, and that gives us 36k minus k squared minus 9 equal to 57 times 3. What's that? 180 minus 9, that will be 171. Okay, that gives me 0 equal to k squared minus 36k plus 180 equal to 0. Can we factorize this now? Add करके we should be getting 180. 30 times 6 will work, right? Yeah. 30 and 6 will work. K squared minus 30k minus 6k plus 180. We get two factors from this, k minus 30 and k minus 6. So k is either equal to 6 or k is equal to 30. Achha. Now the question said, find the value of k. When they say find a specific value of k, it has to be, as in it's a singular, right? It's not plural. There has to be only one possible value. So what should be the value of k then? Is it 6 or 30? Both of them are more than 3. That is one thing. Is 6 possible? Is 6 possible? 6 is possible. Okay. 6 is indeed possible. There's no problem with that. 57, the total distance traveled is this. Yeah, okay. So we're getting two values of k. There's no problem in accepting 6 as a possible answer. So the first time, therefore, when the distance traveled becomes 57, that is when k is equal to 6. That is the value that we take. This will probably happen at some point later when the displacement becomes 30 again. Okay? Distance traveled will become greater than that. So we just take the first value of k that we're getting, the first value of k, that is 6, and that will be our final answer. Okay? Yeah, so afterwards, what happens is, we don't care if it's negative or positive. In fact, it is going to become negative later on, yes. So why are we getting that value 30 in the first place? The reason for that is we are using the displacement function, right? So the displacement at some point later on will again equal 57. Why would that happen? There will be some more positive area here and then some other negative area. Eventually, it will become equal to 57 again. That's not what we're looking for. We're just looking for the first value, and that's this. So we have to ignore the second value. That's necessary. Okay, we have to ignore the second value. Otherwise, you will lose 1 mark because of that. ठीक है? अच्छा. That was question number 11. That was the last part of this. Let's look at the last question now. Question number 12. This is one last question that we want to do from this, then we end. Okay. One last question. Okay. Okay, this doesn't look very difficult. So they're saying the normal to the curve at the point where x is equal to 2 has this equation. Find the values of a and b. What we can do is we can find our own equation and compare it with the one that they gave. That is one possibility. Let's do that. Let's find the equation of the normal and see what that turns out to be. For that, we have to differentiate it first. We have to find the derivative of this first, so it becomes y equals 4x raised to power negative 2. Write it in the power form. Find the derivative dy over dx. It's not that difficult, I think. Multiply by the power minus 8x raised to power negative 3 plus a, that's the derivative. Now you put that value of x here, 2, to find the gradient at this point. That turns out to be dy over dx equal to minus 8 into 2 raised to power minus 3 plus a, which is minus 8 over 8, that is 1, right? Minus 1 plus a. This is the gradient at that point. Now, if that's the gradient, what about the gradient of the normal? This is the gradient of the curve at that point. What about the gradient of the normal? Gradient of the normal, that is going to be negative reciprocal of this. So you can say minus 1 over minus 1 plus a. We can multiply this negative in the denominator, and that will make it 1 over a minus 1. So that's the gradient of the normal. That's the gradient of the normal. Once we've got the gradient of the normal, now we could say, let's zoom in slightly. Okay, once we've got the gradient of the normal, now what we can do is we can say, find the point at which we have to find that normal. Okay, y equals 4 over x squared plus ax plus 7. That's the equation of the curve. Let's input x equal to 2 in the original curve now. See what the y value turns out to be. 4 over 2 squared plus a into 2 plus 7. And that simplifies to 1 plus 2a plus 7, and that is 2a plus 8. That's the y value that we get. So the point that we have got therefore is 2 and 2a plus 8. So now we have a point on the normal and we have the gradient of the normal. We can write down the equation of the normal now. What does that turn out to be? Equation of the normal. Let's write that down. Y minus y1, that means y minus 2a plus 8 equals m, which is 1 over a minus 1 into x minus x1. That will be x minus 2. Simplify this. The final result that we want is in this form. X and y terms on the left side, constant on the right side. Let's just make it that form. Multiply a on the other side, and that will become ay minus y minus a minus 1 into 2a plus 8. On the other side, we have x minus 2. Simplify this. Ay minus y minus a into 2a. That will be minus 2a squared. Or what I'll do is I'll just multiply the two brackets first, so we don't do any sign errors. 2a squared plus 8a minus 2a minus 8. On the other side, we've got x minus 2. Simplify this further. Ay minus y, that minus 2a squared plus minus 8a plus 2a plus 8 minus x plus 2 equal to 0. Now take all constant terms to the other side. Take all constant terms to the other side. Only keep x and y terms on this side. There's only one x term, that is this. We want the x term to be positive, okay? What I'll do is I'll just take the x and y terms to the right side, okay? So x becomes positive. Let's just keep it like this in the previous step. X is on the right side. Let's take y terms on the right side as well. What are the y terms? It'll be plus 1 or minus 1? Plus 1 or minus 1. Okay, yeah, you're right. This should have been 1 minus it. This happens almost every day. At the end of the paper, I end up making careless mistakes like this. This should have been 1 minus a. Yeah, this should have been 1 minus a. Happens almost every day now. That's unfortunate. It happens for a lot of people as well, by the way. At the end of the paper, you have to be extra careful because you're tired at that point, and careless mistakes start happening at that point. So that's something that you have to learn from as well. Now, the gradient is this. When you take negative reciprocal of this, it turns out to be 1 over a minus 1, right? Again, I'm doing the same thing. 1 over 1 minus a. That's the gradient. Write down the equation of the normal. That will be y minus y1, which is y minus 2a plus 8, equals m, which is 1 over 1 minus a into x minus x1. Let's simplify this, multiply this a on the left side. That gives me y into 1 minus a minus 1 minus a into 2a plus 8. On the other side, we've got x minus 2. And that gives me y minus ay minus 2a plus 8 minus 2a squared minus 8a equals x minus 2. Let's simplify this further. Y minus ay minus 2a minus 8 plus 2a squared plus 8a equals x minus 2. Now the equation that they want at the end, is this. So we want x and y terms on one side, only a constant on the other side. Let's convert it to that form. X and y terms on one side. We've got x on the right side already. Let's take all the y terms to the right as well. And that'll become x minus y plus ay. All the constants on the other side. Anything that does not have an x with it, that's a constant. These are all constants, right? So we have 2a squared minus 2a minus 8. Let's add them up together. Minus 2a plus 8a, that will be plus 6a. Minus 8 plus 2 from the other side, that will become minus 6. Okay, this is what we're getting now. This is what we are getting. Now let's make it one term for y on the right side as well. If I take y common, what does that leave me with? Minus 1 plus a inside times y outside. Now, what is it that they wanted? The values of a and b. Okay, this is the equation that we're getting now. The equation that they gave us is x plus 4y. So I can write that here. X plus 4y equal to b. That is equal to b. That's the equation that they gave us. Now let's compare both of them. X is the same in both of them. X is the same in both of them. So that means we can compare them because it's the same coefficient of x in both. So we can compare both sides now. Compare the coefficients of y and the coefficient of x. If you compare the y coefficients, that gives us minus 1 plus a equal to 4, and the value of a turns out to be 5. And if we compare the constant on the other side, that gives us b equal to 2a squared plus 6a minus 6. Now that we've got the value for a, input that here, and that gives us 2 into 5 squared plus 6 into 5 minus 6. Simplify this, that is 50 plus 30 minus 6, and that turns out to be 74. That's the value of b that we are getting. A is 4 and the value of b is 74. That's what we're getting at the end. Okay, that was pretty straightforward, not that difficult. As long as you are not making any careless mistakes, that's the result that we get. ठीक है. Can't we equate once we find the gradient of normal? You can do that, Ahmed, but the problem is we will need another equation, right? That's not going to be enough because when you find the gradient from this, let's think about it. The gradient from this is going to be minus, if I make x the subject, that will give me y the subject, that will give me minus 1 over 4 times x plus b over 4, right? That is what is going to happen. The gradient is minus 1 over 4, so we could compare the gradients, yes. That will give us the value for a. Yes, a we could find using that. Compare this with this. We could find the value of a from that. Once we've got the value for a, then we could say, we could find the y-intercept after that. Maybe we'll have to do simpler working in that case, because once we already have the value for a, this calculation will become simpler. So we'll still find the equation from that. Once we've got the equation, we will compare the y-intercepts and that will give us the value of b. Yeah, so the idea will be the same, but yes, if we find that early, that will make some calculation a bit quicker, yes, a bit more efficient. You're right. You could do that as well. ठीक है. Gradient is 1 over a plus 1, not a minus 1. It is a minus 1 because when you multiply by negative, it becomes 1 minus a, right? This sign changes, this sign also changes. Okay, I hope that makes sense. Yeah, it will make simplification more easier. You're right about that. You're right about that. If we find the value of a first using the gradients, this simplification will become slightly quicker. You're right. It will be less prone to careless errors as well. ठीक है चलिए I hope that was helpful. This is it for today. I'll be continuing these past paper sessions over the next week as well, inshallah, for paper 2. All the best for your exam tomorrow. I hope it goes well, inshallah. Just make sure that you do not panic, as in that's not in your control, but do not get stuck at any question. That's what makes you panic eventually. Don't get stuck at a question. If you can't understand something, leave that. Complete the rest of the paper. The questions that you find easier, make sure that you've attempted all of them first. If you're well prepared, it should be anywhere between nine to 10 questions, maybe. Otherwise, if not well prepared, at least 7 to 8 questions everybody should be able to do if you're taking advanced and have prepared well. Then in the next go, the any parts that you are left with, you attempt them in the next go. Okay, so you'll have enough. You'll have almost half the time left after that point. If, for example, in the first go you attempt around 8 questions, you should try to save time on them. Try to save time on them, the questions that are relatively easier, so that for the more difficult, lengthier questions at the end, you have more time and you can slow down a little and reduce careless errors as well. Okay. I hope you all do well, inshallah. I'll see you again in the next session then, inshallah. Allah Hafiz. Make sure to sleep well as well, by the way, because by the end of the paper, you get extremely tired then if you haven't slept well, and that makes you do a lot of careless errors. So please sleep early, have at least 7 hours of sleep if possible, but definitely not less than 6, and you should be fine, inshallah. Allah Hafiz. All the best. What do I do now? You're welcome. दुआओं में याद रखें. I'll see you in the next class, inshallah.